The Application Lifecycle Risk Management Podcast, Episode 34, String and StringBuilder. A couple of weeks ago, we discussed value types and reference types, where we said that a reference type points to the value it represents, and a value type is the value it represents. This has implications when we work with the assignment operator because when you assign a reference type and change the content of what it is pointing to, both variables get changed because they both point to the same location. If you do this with a value type, only the one you change sees the change because you're working with a copy. So, if you've done any work with a string class, you might think it's a value type because when you write string A equals ABC and string B equals A, string B equals DEF, and then do a console write line on A and B, what you'll quickly discover is that the values that get written out are ABC, DEF, which is not what you'd expect if string is a reference type. So, the question we need to ask is, why is string acting like a value type if it really is a reference type? And the answer is that strings are immutable. That is, a string never changes. And if you're a thinking person, I can already hear you saying, sure they changed. Just look at this code. String A equals ABC. A equals DEF. Console write line should give you DEF. And you'd say, see, I changed the string variable from ABC to DEF. And yes, you did change the variable, but what did you change? You didn't change ABC to DEF. What you changed was what it was pointing to. You see, ABC is the object of type string, and DEF is an object of type string. All you managed to do was change what was being pointed to. In fact, if you write string A equals ABC and string B equals ABC, the result is exactly the same as if you'd written string A equals ABC, string A equals B, because in .NET there is only one instance of any given string in the system. The duplicates get optimized out. Now, all of this has implications when it comes to concatenation. Let's say you write this code. String A equals ABC, string B equals DEF, string C equals A plus B. What's happening here? Well, first we create a string object that contains ABC and point the A variable to it. Then we create another string object that contains DEF and point the B variable to it. And now this is where strings get interesting because the next thing that happens is that a new string object is created that contains ABCDEF, and we point the C variable to that new value. Now, if you think about this for a minute, you'll understand that this is incredibly inefficient. Creating new objects is one of the most expensive operations that anyone can do in just about every object-oriented language that we have available. In fact, I can't think of one where this is not true. I'm just assuming there must be an exception to the rule. It would be much more efficient if we were to make string so that it wasn't immutable. Now, this would mean we would skip the create new object part of the assignment of our concatenation operation, and it would all work much faster. Enter StringBuilder. StringBuilder is essentially the mutable version of the string class. Now you can write code that looks like string A equals ABC, string B equals EFG, string C equals HIJ, var D equals new string builder A, D.append B, D.append C, string E equals D to string. Note, at the end, we still have to convert our string builder object to a string object using toString. So there is a new object creating penalty there. What this means is that you probably don't want to use a string builder unless you are appending to a string more than 3 times. So there you go. That's the difference between string and StringBuilder. Why string looks like a value type, and when you should use StringBuilder instead of string. Don't forget to rate this show in iTunes and Stitcher. What's Stitcher? Stitcher is an award-winning free app that lets you listen to all your favorite shows, plus discover from 20,000 news, entertainment, and sports shows. Create custom playlists. Available on the iOS, Android, and Nook. No downloading, no syncing, no wasted memory. Don't have Stitcher? Download it free today at Stitcher.com or in the App Store. And for the links to items mentioned in this podcast, make sure you check out my blog at blog.dmbcllc.com. A link to this article is in the show description.